Hello, I'm Zachary Frederick, and my partner is Danny Santos, and our project for Dr. Zalewski's computer network class was working with the LEGO EV3 robot. The objective of the project is to control the LEGO EV3 robot and detect objects using the infrared sensor that's provided with the EV3 robot and controlling the robot with the Android application over Wi-Fi. If the infrared sensor detects an object to be too close to the robot, it will not allow the robot to move into the object and will warn the user. The project consisted of the LEGO EV3 robot, the Android application, and the Lehos application running on the EV3 brick. These are our client-side software requirements. The Android application shall be able to establish a secure connection to the EV3 brick over a Wi-Fi. The Android application shall be able to send commands to the motor by the EV3 brick. The Android application shall be able to receive infrared sensor data from the robot through the EV3 brick, and the Android application shall be able to interpret infrared sensor data to notify the user of an object. The EV3 brick side requirements included the EV3 brick shall be able to send commands to the motor through a wired connection. The EV3 brick shall be able to receive messages from the infrared sensor through a wired connection. The EV3 brick shall be able to send data back to the Android application through Wi-Fi. The EV3 brick shall be able to connect to secure Wi-Fi, and the EV3 brick shall be able to interpret commands received by the Android application. A high-level dynamic design of our project can be seen here. The user inputs an IP address. If it's correct, it connects to the robot. They are then able to send commands. The LEGO program will interpret the commands. If an object is too close, it will warn the user of an object and then wait for further commands. But if there's no object in the way and it's clear, the motors will move to the user's desired preference and then wait for further instructions from the user. You will now see our LEGO robot in action. As shown in the dynamic design, the user first has to connect to the robot. As the robot's awaiting the client, the user inputs the IP address and clicks the connect button, and then will connect to the robot. The user can then freely move the robot. As you can see here, it's moving forward. Then it will move to the right, and the user can move the robot any way they desire. If the user keeps on going forward, and an object is near, and the robot can't move forward anymore, the distance to the object, as shown here, will be sent back through the socket to warn the user, as you can see at the bottom of the screen, that an object is too close. The user then tries to click forward again and can't move forward, and so the robot will not allow the user to back into the object. Once the user backs up, they're free to move about as they please. As you can see from the demo, our test cases that have all been met. The Android application was successfully able to connect to the EV3 brick over the IP address. The EV3 brick displayed the distance measured by the infrared sensor to the nearest object. The EV3 brick is sending infrared data to the Android application over the Wi-Fi connection and warning the user that object is too close. The Android application is able to interpret the infrared data sent to it to warn the user that the object is too close. And the Android application is able to send motor commands to the EV3 brick, and the EV3 brick interprets those commands and moves the robot accordingly. Overall, the project met all the desired requirements that we specified at the beginning of the project. The infrared sensor was able to detect objects in front of it relatively accurately to warn the user not to move into that object. Future implementations can include a better infrared sensor to give the user a better understanding what's around the robot, and implementing all the motors the robot has to give the user full control of the robot.